this lecture, I'm going to talk about regular expressions. This lecture is actually unique in the series of lectures that I've done so far, in that it's not actually a lecture about R. I won't be talking about any R in this lecture at all. I'm just going to be talking about regular expressions, which is a general idea that applies to many different programming languages, not just R. Some of the programming languages that are probably most popular for using regular expressions are languages like Perl or Python, which are kind of built around these types of things. So, what are regular expressions? The basic idea behind regular expressions is that you want to be able to represent language in certain ways, and in particular, language that you'll find in text files. You want to be able to kind of parse or search through the text to look for certain types of things. And in our context, we're going to want to look through text files or text in general to look for data or things that we're going to be interesting that we think are interesting that we can turn into data. And so regular expressions can be thought of as a combination of things called literals and things called meta characters. So literals are, if you want to draw an analogy with natural language, for example, like English, literals are you can think of as being the text, like the words on a page, or the words on this slide, for example, are all literal words, and the literals form the words of the language, while the meta characters are essentially they define the grammar. And so you think of a word like verb or noun; those are words that describe an entire class of words, and so they're in some sense they're kind of meta characters for the English language. So regular expressions for programming languages have a rich set of meta characters that can be used and combined in a number of ways to describe a whole classes of words or literals. So the simplest pattern that you can create using regular expressions is a literal. And a literal is just a word, it's a string of characters together. So for example, the word nuclear here is a literal. It's a string of characters, and you might want to search through a text file and match every line in the file that has the word nuclear in it. Okay, so here are a couple examples of text lines of text that have the word nuclear in it. And even though some of these lines of text are on multiple lines, I've just done that just because otherwise they wouldn't fit on the screen. So just imagine that each block of text is on a single line. So the first one has the word nuclear blast. The second one has nuclear weapons. Then the fourth one here has nuclear physics, and then the last one here says nuclear people. So all of these lines of text have the word nuclear in it, and they're all spelled exactly the same way. And they're all in all lowercase letters, so there's no deviation from the word that we were looking for. So that's how a literal expression works. Here's another example of a literal expression that you could use to match with text. And so a couple of lines of text here that have the word Obama. Now keep in mind that the spelling of the word here, capital O, B, lowercase b a m a. It's very important. If you use this as a regular expression and search through text using whatever software you're going to be using, you will only match lines that have the literal phrase spelled in exactly this way with this combination of capital and lowercase letters. By the way, I should mention that I'm not going to talk about software in this lecture, but I will talk about the functions in R that you'll use to actually do this kind of searching through text in the next lecture on regular expressions. So this is another example of a literal string, and these are lines of text that would match it. So the simplest patterns for regular expressions consist of only of literals, so you're looking for specific words, and a match will occur if a sequence of if these literals occur anywhere in the text that's being tested, so anywhere in the line of text. But what if you want to look for something that's slightly more complicated? For example, you might look for the word Clinton with a capital C or Clinton with a lowercase c. Or maybe someone slightly misspells the word, maybe drops the N, but you want to look for that too because they're probably talking about the same thing. So now I've got a class of words, not just a single word, and I want to be able to represent this class of words using some sequence of some expression, and that's where regular expressions start to show their strength. And so, in general, we need ways to express things like white space word boundaries, sets of literals, so classes of words or phrases. We want to know whether we're at the beginning of the or at the end of a line, and we might want to specify things like alternatives, so search for war or peace, rather than just search for war or just search for peace. And that's where meta characters come into play. So the first meta character that we'll talk about here is the caret here, and the caret is something that can represent the start of a line. So if I say caret, I think, what will this search for? So this will search for the word, the phrase I think, or I should more specifically, it'll search for the phrase I space and then THINK in lowercase letters. At the beginning of the line only. So here we have five different lines of text, all of which start with the phrase "I think." So if you had a line of text where "I think" occurred somewhere in the middle of the phrase or of the line, that would not match this regular expression. So this is a way to say I wanna match a certain string of text that only occurs at the beginning of a line. The dollar sign is used to represent the end of a line. So this is the opposite of the caret. And so if you want to, for example, look for some text that looks for a line of text that ends in a certain word, for example, the word morning, then you can use the morning dollar sign, and you'll look for, and it will match lines of text that end with the word morning. So you can see all these lines of text here end with the word morning. Another way we can describe classes of characters or words is with character classes. And character classes are denoted by the square brackets here. So for example, it is often the case that we may want to specify a bunch of characters that can match at any given place. So for example, here I've got the word bush, B-U-S-H, but for each of the letters, I'm willing to accept either a capital letter or a lowercase version of that letter. So here I've got the first character class is capital B or lowercase b, followed by a capital U or lowercase u, followed by a capital S or lowercase s, and then a capital H or lowercase h. So this allows for a variety of different spellings of the word bush. And so in cases where people may be misspelling the word or maybe forget to capitalize or things like that. And so these are a couple of lines of text that will match this expression, and you can see that that the word bush is spelled in a variety of ways, sometimes with uppercase b, sometimes with lowercase b, etc. And so that's how we can use a character class to specify a variety of types of letters that can be matched at the same time. So now we can start combining regular expressions or meta characters to create kind of more powerful expressions. So here I've got a caret and then followed by a character class. So what is this saying? This is saying that I want to match any phrase that starts with the words I am, where I can be lowercase or uppercase. So here are some phrases or lines of text that match this regular expression here. So notice that they all start with the words I am, but sometimes it's lowercase and sometimes it's uppercase. You can also specify ranges of letters using the square bracket character class. So for example, if you have A-Z in the square brackets, that means you can match any letter between A to Z. So any letter basically in the English alphabet that's lowercase. And if you have capital A to Z, that means uppercase letters in the English alphabet. And if you have A to Z lowercase and A to Z uppercase, then that means I can take any uppercase or any lowercase letter. And so the order here doesn't matter. So now if I combine, say, the caret with the class 0-9, so that means any digit between 0 and 9, followed by any letter between A to Z, uppercase or lowercase. So this regular expression says basically I want a line of text that starts with a number and is followed with a letter. So here are a couple lines of text that match this expression, and you can see that every line starts with a single number and then is followed by a letter. And so that's what the expression is asking for. So we talked about the caret already, and the caret can be used in a regular expression to indicate the beginning of a line. However, if you use the caret inside of a character class, or inside a square bracket, it takes on a different meaning. So if you use the caret inside a character class, it's used to indicate kind of a negation, or the idea that you want to match characters that are not in this class. And so if you look at this expression here, you'll see in the character class I've got a caret and then a question mark and a period, and then followed by a dollar sign. So what does this mean? So this means I want to match lines of text that do not end in a question mark or a period. Okay, so if you look at the lines of text that match this, you see that none of these lines of text have a question mark or a period at the end. One of these lines has an exclamation point at the end, but that's okay because it wasn't in the character class. And so, and then the last line here does have a question mark in it, but that's okay because it's not at the end of the line. So the period is used to refer to any character. So it's a special meta character that can be used to reference anything. So for example, if you have a expression 9.11, or more specifically 9.11, what will that match? So what that expression is saying is that you have a literal 9 followed by this period meta character followed by two ones, which are both literals. And so what does that mean? That means I can match 9 and then anything and then followed by a 1, 1. So here are a couple of lines of text that do match that expression. So for example, in the first one you have 9-11. In the second line you have 9/11. In the third one here you've got an IP address, and you see in the middle there is a 9 with a literal period 11. In the fourth line I've got a 9, a colon followed by 11. And then in the last one I've got a whole string of digits, and you'll see embedded in that long string of digits there is a 9 followed by two ones. And one of the things that's special about the period is that the period can match nothing. So it can match a character, but it can also match nothing. And so nothing is one of the possible sets of things that it can match. So that's why 911 will also match that expression. So the vertical line here, which is sometimes called a pipe or a solidus, can be used in regular expressions to indicate alternatives. And so, for example, if you want to match a word or another word, you can use the pipe to do that. So here I have flood or fire. So if I use this expression on lines of text, if that line of text has the word flood or fire in it, then it will satisfy the match. So both flood and fire are literals, and so they have to match exactly, but you can match either word. So you can see that these lines of text do match that expression. So for example, the first line we have fire wire, so fire matches there. The second line has global flood, so flood matches there. The second line just has the word fire by itself, and the last one has the word flood in it. So all of these lines will match that expression. You can put a bunch of alternatives together. So here I've got flood, earthquake, hurricane, and cold fire. So if a line of text has any one of these words in it, it will match the expression. And so here are a couple lines of text that do match that. And now if you use the pipe or the solidus to express alternatives, they don't just have to be literal expressions. You can have regular expressions as the alternative. So here I've got a regular expression that says, on the one hand, I can have the word good at the beginning of the line, or I can have the word bad. And then for either good or bad, they can start with a capital or a lowercase letter. And so here are a couple of lines that match this expression. And so you notice that in the fourth line, it doesn't match the word good at the beginning. But it does match the word bad somewhere in the middle. Similarly, the last line, it doesn't match the word good in the beginning, but it does match the word bad towards the end. But then the first three lines match the word good in the beginning, so they match right away. So one of the things that you might want to do, for example, in the previous expression, I said it said match the word good at the beginning or the word bad, but you might want to just match the word good or bad at the beginning. And so here I've wrapped the good or bad in the parentheses and then put the caret outside that. So now when you look at the lines of text that match this expression, you'll see that both the good and the bad word have to be at the beginning of the line and not just the word good. So we talked about the use. Well, no, sorry, we're going to talk about the use of the the use of the question mark here, and the use of the question mark here can indicate that an expression is optional. So, for example, here I'm looking for the phrase George W. Bush. Now, I've combined some character classes and an optional element. So here the G can be lowercase or uppercase, the first G that is. The B and Bush can be lowercase or uppercase. The W, which is the middle initial, can be lowercase or uppercase, and then followed by a period. So notice that here I'm using the period, but I'm not using it to indicate any character like I did before. And the reason that I know that is because I've preceded it with a backslash. So this is sometimes called escaping a character, because sometimes you don't want to use a meta character as a meta character. You want to use it as a literal character. So sometimes you're searching for something like a period, and you don't want that to be interpreted as a meta character, and so you can precede it with a backslash, and that will tell the interpreter to say, okay, I'm not looking for the period as a meta character, I'm looking for an actual period. So here the expression says I'm looking for the word George followed by a space, followed by a W, followed by a period, and then followed by a space, and then followed by the word Bush. And the question mark means that the thing that's in the parentheses is optional. And so I don't have to have a W in the middle there, but if I have a W there, then it's fine. So you can see that the first line matches the word George Bush, all lowercase. The second line matches the word George W. Bush, and then the last line matches the word George and then Bushes, even though the second word is Bushes, that does match the expression, because there's nothing in the expression that says that you can't follow the word Bushes with an E and an S. So that's the use of the question mark to mark optional characters. I talked about how the period here is escape, so it can be matched as a literal period. So the asterisk or the star and the plus signs are special meta characters that indicate repetition, and so usually they're added after a certain meta character or a certain literal, and they're meant to mean I'm going to repeat whatever precedes me any number of times. So the star means I'm going to repeat the thing that precedes me any number of times, including no times at all. And the plus sign means I'm going to repeat what precedes me at least one time. So, for example, if I say dot star, that means I'm looking for a dot. So the dot represents any character, and then I'm going to repeat it any number of times, including no times. Right? So dot star will match all of these lines of text here. So and so in particular, it's looking for parentheses, and then followed by anything, and then followed by a closed parentheses. So here in the first line, I've got 24, comma M, comma Germany. In parentheses, I've got, and then the second line, I've got East area plus drive plus webcam in parentheses. And look in the last line, I've just got two sets of parentheses with nothing in them, and that's okay because the dot can match nothing, and the star can repeat it any number of times, including no times. So the fourth line of text here has nothing repeated no times, and so that matches the expression. So here, this is a slightly more complicated expression, so let's go through it carefully. I've got a character class here indicated 0 through 9. And then I've got a plus next to it, and so that means the character class can be repeated at least one time. So there has to be at least one number from this character class repeated, then followed by space, and then followed by dot star. And so the dot star means anything, really, repeated any number of times, and then followed by the character class 0 through 9 repeated at least one time. So what does that match? Well, the first line here, I've got 720, so I've got 720 followed by a space, followed by this MP battalion, comma, and then space, and then 42. So that matches the pattern. So I got a set of digits followed by a space, followed by anything, followed by a set of digits, and that's it. So that's the pattern. So you can see all of these lines of text will match this pattern that we have. So the curly braces can be used to identify interval quantifiers. So for example, if you want to do something between a certain number of one number and another number of times, so you can specify the minimum and maximum number of matches for an expression. So let's take a look at this expression, which looks very complicated, but so we'll break it down. So the first part of the expression is the word bush, and the B is in a character class, so it can be uppercase or lowercase. And then followed by, and you can ignore the parentheses for now, but so followed by a space, which may be repeated more than one or more times. Followed by, and then I've got a caret in a space. So the caret, remember, inside the brackets means the negation. So I'm going to have a space followed by something that's not a space, and whatever that something is not a space can be repeated at least one time, and then followed by a space repeated at least one time, and then that whole thing can be repeated between 1 and 5 times. So what does that mean? And then followed by a space and followed by the word debate. So what does that mean? That means, so the thing I've got in parentheses here is a space, at least one space, followed by something that's not a space at least one time, followed by a space. And so essentially that's what you might think of as a word. It's a space followed by something that's a non-space followed by a space. It's a word. And so what this is saying is that I'm going to look for the word bush followed by between 1 and 5 words, and then the word debate. So you can see the first line here. It says bush, and then somewhere down the line you see the word debate. And then in between you have the pattern has, and then space has space, and then space historically space, and then space one space, space all space, and then space major space. Right? So that's that pattern repeated 5 times. And so you can look at all of these lines here, and it's always the word bush followed by a couple of different words, and then ending with the word debate, or maybe not ending, but followed by the word debate. And so that's a way to specify a variable number of repetitions in a regular expression using the curly braces. The curly braces don't always have to have 2 numbers. If you have 2 numbers in them, that means you want to range between the number m and the number n. If you just have one number in it, that means you want to match it exactly that many times. And if you have a number with a comma but no second number, that means you want to match it at least that many times. So in most implementations of regular expressions, you can use the parentheses to limit the scope of alternatives divided by the solidus or the pipe. It can also be used to remember text in a regular expression, and so these are sometimes called parenthesized sub-expressions. And this can be very powerful when to make very kind of interesting regular expressions. And then you can match those parenthesized sub-expressions with the \1 or the \2. So let's take a look at this expression right here. So what is this doing? So the first thing it does is it has a space with a plus after it. So the space with the plus means I want to look for at least one space. And then I've got parentheses, and then inside the parenthesized sub-expression, I've got this character class, which is A to Z lowercase or A to Z uppercase. So any combination of characters repeated at least one time. So basically any combination of characters, uppercase or lowercase. And then followed by a space with a plus, so at least one space. And then followed by this \1. And so the \1 basically says put in here whatever was in the parenthesized expression. So essentially just repeat it again, and then follow it with a space and a plus, so at least one space. So basically what this expression is finding is it's finding instances where you have a set of characters A to Z, and then they're repeated twice, right? So if you look at the first line, it says time for bed, night, night. So the word night matches the expression, and then it just repeats it right after that. So that's where the \1 comes in. Same with blah, blah, and same with so, same with all, and anybody, anybody, or CSS, CSS, right? So this expression finds instances where any word is repeated. So notice that it doesn't look for a specific word to be repeated. It looks for any word to be repeated, and in order to do that, you have to use this \1, this back reference type of approach, because you don't know what the pattern is going to match in advance, and so you just say, okay, well, whatever it matched, just repeat it again. So I want to talk a little bit about the star meta character because it has a special behavior in the sense in that it's greedy. So the star will always match the longest possible string that satisfies the regular expression. So take a look at this regular expression here, which is a caret s and followed by a dot star and then followed by an s. So what this regular expression is saying is I want to start the string with an s, a lowercase s, and then follow it with anything repeated any number of times, including 0 times, and then end it with and then followed by an s. All right. So what does this expression match? Well, it matches all of these lines of text here. Now, if you look at the first one, for example, you'll see that it starts with an S and is sitting at Starbucks. And so the word Starbucks actually has an S in the beginning, but that's not where the match ends. The match actually goes all the way to the end of the line because the regular expression will find the longest possible string that satisfies the match. So it could have stopped at the first S in Starbucks, but actually it goes to the last S, and that's the entire match. Same with setting up MySQL and Rails. It starts with S, so it's fine. Setting up now it could have ended with the S in MySQL, but it will go all the way to the end of the word Rails. And so the star meta character is greedy in the sense that it will always look for the longest possible string that still satisfies the regular expression. And there's a way to turn this off, this behavior off, by using the question mark. So if I use the same expression here, and I say dot star question mark, what the question mark does here is it tells the star meta character to be lazy. And so instead of finding the longest possible match string that matches the regular expression, it will find the first possible string that matches the regular expression. So basically the shortest one. And so we'll see how this works in the next lecture in terms of what it will match and what strings it will produce. So that's a very brief overview of regular expressions. There are, of course, whole books written about this topic, and I haven't had a chance to really to do more than really just scratch the surface. But I think some of the things that we've talked about here can be very useful when you're processing text information and trying to create useful data from text files. And so just to summarize here, regular expressions are used in many different languages. They're definitely not unique to R. And basically regular expressions are composed of combinations of literals and meta characters that represent sets or classes of characters and words. And it's important to realize that text processing using regular expressions is a very powerful way to extract data from sources that are kind of not friendly. For example, from websites or from text files that are messy or they're not properly formatted. And it's important to realize that not all useful data comes in the form of a nicely formatted CSV file. So in the next lecture, I'm going to talk about the functions in R that can be used to process regular expressions, and I'll have an example data set there that we'll use to process text and get some data out of.